Remember, we try to construct an interval. That will catch mu or pi with a big probability. How big is it in this case? 95%. 95%. Do you still remember the 68, 95, 99.7 rule? What is this 95 here? It says within what? 2 sigma around the center, the area should cover what? 95%. But it's 2 sigma for standard normal is from 2 to minus 2. But that's just approximately 95%. If you look for exactly 95%, this is not 2, this is not minus 2. If you check your table, the closest number should be what? 1.95, and this one should be minus 1.95. It's not 2, although it's very close to 2, okay? And based on this understanding, let's move to the next sentence, next expression, okay? Now look at here. Z-score between 1.95 to minus 1.95 cover the area about 95%, okay? And where is Z-score coming from, okay? Z-score is you standardize what? X-score, X-bar, right? Okay? X-bar, you subtract by EV X-bar, expected value of X-bar, and then divided by SE X-bar, or standard deviation of X-bar. You get what? You get X-bar minus mu, and the denominator is sigma over square root n. So this expression is Z-score. We're going to replace what? Z-score by this expression, okay? So Z-score, X bar minus mu over sigma divided by square root n. This is Z-score. Z-score between 1.95 to minus 1.95 covers 95% of the area. This sigma here, reminds you, is standard deviation of the box. Or you say this is population standard deviation, okay? Now, what do you know about sigma over square root n? Sigma is standard deviation. Sample size. So this number must be greater than 0. If you multiply this number to all 3 terms, but this is positive, so you won't change the direction of the inequality, okay? So sigma over square root n times minus 1.95, you have minus 1.95 times sigma over square root n. And sigma over square root n times sigma over square root n, this cancel, right? So what's left? You have X bar minus mu, okay? And this term, 1.95 times sigma over square root n, this is my right-hand side of the equality, okay? So this expression can be rewrite as probability that minus 1.95 sigma over square root n to 1.95 times sigma over square root n will cover X bar minus mu with 95% of chance, okay? Now, from here to here, students always ask me, Scott, why you write the same expression again? Are they the same? They are not the same. Where is the difference from here to here, right? So what happened from here to here? Let's see. This is what you learned in high school. If you say A is between 1 and 3, and you times minus 1 to 3, the largest one becomes the smallest one, minus 3. And the smallest one now becomes the largest one, minus 1. And middle one just changes the sign, okay? Now, how about this case? B between minus 2 and 2, okay? If I times minus 1, the largest one becomes smallest one, minus 2. If I times minus 1 to minus 2, it becomes the largest one, which is 2. And middle one just changes the sign. So you learn, when the endpoints have the same absolute value, when you do this kind of operation, you find endpoints remain unchanged, only the middle one changes the sign. That's exactly what happened from here to here, okay? So next, if we add X bar to all 3 terms, X bar minus this term, and X bar plus this term, okay? And how about the middle one? I add X bar, this is minus X bar, become mu. So this is X bar minus H to X bar plus H. 1.95 times sigma over square root n, I call this is H, Okay, I call this is h. And x bar minus h to x bar plus h is exactly what we try to find. Okay, I say I use x bar as a center, try to build a narrow interval that will cover mu with a big probability. In this case, it's 95%. Okay, but how do I know h can be small? Very easy. When you increase sample size, h can be as small as you like. Is that okay? So that is to say x bar minus h to x bar plus h is a 95% confidence interval for me. Is that okay? Okay?